Hi there, welcome back. What we're going to be doing now is actually sort of backwards work. We've spent a fair amount of time learning how to solve a quadratic equation, finding its roots. What we're going to do now is kind of the backwards. I'm going to say, okay, if we know what the roots are, what might the equation have been? So let's recall something. We know that if we're solving a quadratic equation, let's say it's already in factored form. So it's something like x minus a times x minus b is equal to 0. What that means is the roots, or the solutions, are x is equal to a and x is equal to b. So this implies that, but also this statement implies that. So for example, if I tell you that 2 and 3 are the roots of a quadratic equation, well, they would have come from this factored form, right? And so the quadratic equation that has 2 and 3 as roots would be x squared minus 5x plus 6 is equal to 0. So it's all about writing it in factored form given the roots, and then just multiplying it out. So theory is very, very simple, and most of the work here is simple too. So suppose we say that we have a quadratic equation and the roots are 3/2 and minus 5. I could write x minus 3/2, but it's much nicer to write 2x minus 3, right? Because now we're dealing with just integers, and x plus 5. So this factor will give me minus 3/2 as a root. Give me 3/2 as a root, and this factor will give me minus 5 as a root. So if I multiply them out, I get 2x squared plus 7x minus 15 is equal to 0. So this is the quadratic equation, which has 3/2 and minus 5 as roots. What could be simpler than that? Okay, so here's another one. A little bit different with square roots, but if square root of 5 is a root, then it would have come from that factor. And similarly here. Now that's of the form a plus b, a minus b, so the outside and inside terms cancel, and all I get here is x squared minus 5 is equal to 0. Right? Isn't it nice to have some work that's kind of easy? Wow, so this looks a lot messier. And until you get the trick on this, it could be a little bit messy. You certainly wouldn't want to write x minus 2 plus 3 square root of 2 times x minus 2 minus 3 square root of 2 and multiply those out. But look, let's look at it like this. What we know the roots are 2 plus or minus 3 square root of 2. Now that's the same thing as saying that x minus 2 is equal to plus or minus 3 square root of 2. And so what I can do here very cleverly is square both sides. And so on the left, what I get is x squared minus 4x plus 4. And on the right, if I square plus 3 square root of 2 or minus 3 square root of 2, what I get is 9 times 2, or 18. And so therefore, look how nice this works out. There we go. There's the equation that has these two puppies as roots. All right, let's try one more. Wow, check this one out. Pretty ugly. And this would be a case of a quadratic equation that has imaginary roots. And that would happen if we're using the quadratic formula and the expression under the radical, which is b squared minus 4ac, turns out to be negative. That's what will give us imaginary solutions or complex solutions. But what we're going to do here is exactly the same as what we did before. We're going to write this as x is equal to 3 plus or minus 5i all over 2. Multiply both sides by 2 and subtract 3, and I get 2x minus 3 is equal to plus or minus 5i. With me? It's kind of fun. Square both sides, and what I get on the left is 4x squared minus 12x plus 9 equals. Now, whether I square plus 5i or minus 5i, I get 25i squared. And remember, I squared is minus 1, so I have minus 25. And so I add 25 to both sides, and here is my equation that has these ugly things as roots. Alright? That was kind of fun. And that's it for this particular section. See you next time.